Okay, so we have a regular polygon. Alright, now this is not good advice, but this is what I'm going to do before I even answer the rest of the question. I've got a regular polygon. My brain is going to automatically, without reading the rest of it, okay, I've not read anything. All I read was regular octagon, regular polygon. So I'm going to do 360 divided by the number of sides to get this. I'm going to do it straight away without even thinking about what it's doing. Now, this is not good practice, but this is going to ensure that if I'm near the end of this paper, I can at least get 1 or 2. Now, that's the exterior. To find the interior, I'm going to do 180, take away 45. So I'm doing that now. So that's 135. And what that's doing, it shows that every angle in the whole thing is 135. Now, I'm not touching this bit because there's a bit more information going on here. But this bit so far, they're 135. Okay, so now I'm going to carry on. Okay, and just see what the question's asking me. So, ADG is a straight line, so this is a straight line. So, all that makes 180. And actually, the bottom, all that's 180. Okay. BAD and CDA. BAD and CDA. These two are the same. So, these are the same. So, I can put X and X, they're just the same. Okay. Show that angle CDJ, this one, show that that equals 135. That's what we've got to show. Okay. So we've figured out these interior angles, and this is a trapezium, but it's an isosceles trapezium, which means it's got a line of symmetry. So these are the same. These are 135 because they come from what we figured out. So if I add those together, I've got 270. So if I take that away from 360, which is 90, because it's a four-sided shape, you'll have 360 degrees in the quadrilateral. If I halve that, these are 45. So if I put that up here, this is also 45 here. And because this is on a straight line, you can do 180, take away 45 to show that equals 135. Okay, so although it wasn't fantastic practice, finding the interior and exterior angle now, or before I read the question, just helped. It meant that this was a lot easier to process, and you do get credit. I think you got 1 mark or 2 marks for seeing these values like that. Okay, so I did show it. And that's it. So that's an extra 4. It takes me to 71. Right, this was a beast of a question. They didn't need to make it this hard. Okay, but they did. So we're going to have to deal with it. So the idea is we substitute x into the equation. I'm just going to make this a bit bigger. There we go. Focus it. There we go. So we're going to cube x, and square x, then take away 2x and add 1. So this is going to look like this. So 2, I'm doing I always start from the positive end. 2 cubed, add 2 squared, take away 2 times 2, add 1. This is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 2 squared is 4. Take away 2 times 2, which is 4, add 1. 8 add 4 is 12, take away 4 is 8, add that is 9. Well, let's do 0. 0 cubed, add 0 squared, take away 2 times nothing, add 1. Anything, well, 0 cubed is nothing, 0 squared is nothing, 2 times 0 is nothing, so it leaves 1. Okay? So that bit so far will potentially get us 1 if we've got 2 values done. And I've avoided the negative because that's the bit where mistakes will come in, but I've got to do it now. So minus 3 cubed, add minus 3 squared, take away 2 times minus 3, add 1. 3 times 3 times 3 is 27. 3 3s are 9. 9 times 3 is 27. An odd amount of negatives, because you've got minus 3 times minus 3 times minus 3. An odd amount of negatives will make a negative. 3 squared is 9. There's 2 negatives, so it's positive. 2 times 3 is 6. You've got 2 negatives, that's positive. And then add 1. Okay? So that's what I've got to do. So I'm at minus 27. I've got to, let's just bring this in. If you can see it all on the same bit, that'll be better. At minus 27, I've got to add 9. So if I added 10, that'll take me to minus 17, but it's minus 18. Then I've got to add 6, 6 means 12. And I've got to add 1, so that's minus 11. Okay, so once the table's sorted, the other parts are just easy marks. You've just got to plot these. So let's plot them. So it goes 2, 9, 1, 1, 0, 1, and so on. They're the coordinates that you can make. So 2, 9. This bit's 10. So let's get your scale sorted. That's 10. So in the middle, that's going to be where 9 is. Okay. 1, 1. That bit's 2. So this is where 1 is. So 1, 1 will be here. That's what 2 is. Shouldn't put a coordinate there. Okay, in actual fact, it'd be way easier if I just did those. 0, 1, which is right there in the middle. Minus 1, 3. So minus 3 is there. Sorry, minus 1, 3, which is here. And then minus 2, 1. There. Minus 3, minus 11, which is all the way down here. Oh, that's minus 10. Okay, so this is the graph. It's cubic, so expect this shape. Okay, I missed that one. I should have taken a bit more care there. Okay, last one. Really weird, really awkward. It's a good one to look at in terms of practice because there's loads of different ways you can do this, and you can think about anything. What I'm going to show you now is just that if you weren't trying to get the full answer because you don't understand, how could you get 1? Now you could get 1 mark now by finding the nth term of this. This says here are the first 5 terms of an arithmetic sequence, so a sequence that just goes up like this. Nth term of different sequence is that. So this is not the nth term to that, it's a different one. The last term of each of the sequence is the same number. So at some point, this nth term is the same as our sequence, our nth term. So we're going to find the nth term. There are the same number of terms of each sequence. Find the number of terms in each sequence. Okay. So at one point, this is equal to our nth term. So we're going to find the nth term first. So the gap is 5. So put 5n. Go back 5. That takes to minus 3. So our nth term is 5n minus 3. So 5n minus 3 was equal, or is equal to this at this value, this number, this term. Okay, so we're going to solve this. We're going to take away 4n. So n minus 3 equals 15. Okay, because I've taken it off both sides. I'm going to add 3. So n equals 18. So the number of terms in each sequence, 18. For you to get 1 on the last question, finding the nth term is not a big ask. Okay, the rest of it was tricky. Okay, but that's where it overlaps with your higher.